This is ProjMo example video 1. Brian is standing on the edge of a cliff wondering how high up he is. He takes a rock and tosses it horizontally and times how long it takes to hit the ground below. If it takes 5.7 seconds, how high is the cliff? We have read it. Now we need to draw out a picture. Here is the cliff, and here is the starting point. It goes in a nice parabolic path downward. Now we need to label our diagram. We are noticing it moves from this point down to here, and that is going to be the displacement on the y-axis. It moves across to there, that is the displacement on the x-axis, which they don't actually talk to us about, but it is important to realize. And we should also take into account that the acceleration due to gravity is going downwards. We need to next list out our information. So we are going to focus on the y-axis here. Initial velocity, final velocity, acceleration, displacement, and time. It doesn't say anything about him throwing it up or downwards. In fact, it specifically says horizontally. So that means the initial velocity on the y is going to be 0. The final velocity, I don't really care about. The acceleration is going to be g, which is negative 9.8 meters per second squared. The displacement, that's what I'm focused on. And the time is 5.7 seconds. So I'm going to be looking for an equation without final velocity in it. So using the big 5, d equals VIT plus 1/2 AT squared. Initial velocity is 0, so that goes away. And it's already solved for me. D equals 1/2 AT squared. As you can see, this is just like the big 5 acceleration problems due to gravity that we had done before. So should be nice and easy for us. If we just plug in, D equals 1/2 negative 9.8 meters per second squared, and then times the time, which was 5.7 seconds. That is quantity squared. We tap into our calculator. We get D equals negative 159.2 meters. Now, taking into account that it is asking us how high the cliff is, we're looking for a height. Height is a scalar. We don't worry about the negative sign there. And then using sig figs, that should be 160 meters is the height.